Imagine becoming the world's first trillionaire, not by investing in earthly ventures, but by mining in the depths of space. What would that mean for our global economy? Let's take a moment to ponder the magnitude of this idea. The notion of space mining has been floating around for some time, but it's only recently that we've begun to understand its true potential. Our solar system, it turns out, is a treasure trove of resources. It's estimated that the value of minerals in our solar system is a staggering $100 billion per person on Earth. Yes, you heard that right. Now let's take a step back and consider what that could mean. What if someone managed to tap into these resources? The first person to exploit these celestial riches could become the world's first trillionaire. Just imagine the impact that could have on our global economy. We're talking about a seismic shift here. The influx of these resources into our economy could cause the price of gold and other precious minerals to plummet. We could be looking at a complete redefinition of wealth and resource distribution. But this isn't just about the potential financial benefits. It's about pushing the boundaries of human achievement. It's about exploring the unknown and expanding our horizons. It's about venturing into space, not just to explore, but to harness its resources for the betterment of mankind. However, it's not all rosy. There are significant challenges and risks associated with space mining. There's the technological hurdle of developing the machinery capable of extracting these resources. There's the astronomical cost of space travel. And there's the ethical question of whether we have the right to exploit these resources in the first place. But before we start packing our bags for a space mining expedition, we have to ask ourselves, is it even possible? The story begins with a Spanish astronomer, Javier Jimenez, who dared to suggest that Saturn's moon, Titan, could hold an atmosphere. A daring thought indeed, considering the frigid and inhospitable nature of space that we were accustomed to. Jimenez, with his sharp intuition and profound knowledge of celestial bodies, theorized that Titan, unlike most moons in our solar system, could harbor an atmosphere. It was an idea that intrigued and puzzled the scientific community, a conjecture that remained unverified for years. Fast forward to the year 2013, and the Cassini spacecraft, a marvel of human technology and innovation, confirmed Jimenez's audacious theory. Yes, Titan, the largest moon of Saturn, did indeed hold an atmosphere, a fact that reshaped our understanding of this celestial body. But the revelations didn't stop there. The Cassini spacecraft also discovered fascinating similarities between Titan's atmosphere and our own. Just like Earth, Titan exhibited weather patterns and storms, an indication of dynamic and complex atmospheric processes at play. Yet, despite the startling similarities, Titan's atmosphere is fundamentally different from ours. It's composed primarily of nitrogen, just like Earth. But it also contains a significant amount of methane and traces of other hydrocarbons. And it is these hydrocarbons that make Titan a subject of immense interest and potential. Imagine a world where it rains methane and ethane, where lakes, rivers and seas are filled not with water, but with liquid hydrocarbons. Yes, that's Titan for you, a world that seems to have walked straight out of a science fiction novel. And here's the most astonishing part. Titan's hydrocarbon reserves are massive, dwarfing the combined oil reserves of our entire planet. It's estimated that Titan holds 40 times more hydrocarbons than all the oil wells on Earth. A mind-boggling statistic, isn't it? And it wasn't just the atmosphere that caught our attention. Beneath it lay vast resources that could potentially transform our economy. Beneath the cloudy atmosphere of Titan, we found something extraordinary. A wealth of hydrocarbons, 40 times more than all the oil wells on Earth. Imagine, if you will, the scene. In the distant reaches of our solar system, orbiting the ringed giant Saturn, lies a moon shrouded in mystery. This moon, Titan, is unique, a world unlike any other in our celestial neighborhood. Beneath its thick, hazy atmosphere, vast bodies of liquid methane and hydrocarbon deserts stretch out, painting a picture that seems more science fiction than science fact. Yet this isn't the work of an imaginative author, but the reality of our universe. The Cassini spacecraft confirmed it in 2013. Titan's atmosphere, with its storms and weather patterns, is eerily similar to our own. But it's what lies beneath that atmosphere that truly piques our interest. Titan is teeming with hydrocarbons, the primary component in fossil fuels. In fact, it has 40 times more hydrocarbons than all the oil wells on Earth combined. The implications are vast. Imagine if we could tap into this resource. The energy crisis, a thing of the past. Dependence on earthbound fossil fuels, eliminated. The potential is almost too vast to comprehend. But let's not get ahead of ourselves. The technology to extract these resources does not currently exist. The harsh conditions on Titan, coupled with the sheer distance from Earth, present formidable challenges. Yet we can't ignore the potential. The seeds of space mining, once a concept relegated to the realm of science fiction, are beginning to take root in reality. The economic implications of such a discovery are staggering, but they come with their own set of challenges. Mining on Titan could be the start of a new era, but the road there is fraught with difficulties. The challenges are substantial, from the technological constraints of reaching and mining in such extreme conditions to the potential environmental impacts of extracting vast amounts of hydrocarbons. The technology to tap into these resources is not yet within our grasp, and the long-term effects on Titan's unique ecosystem are unknown. But let's consider the potential benefits. Picture a global economy bolstered by an influx of resources, the value of which is estimated to be around $100 billion for every person on Earth. This could lead to significant drops in the price of gold and other minerals, and the first person to successfully exploit these resources could become the world's first trillionaire. However, as we contemplate these staggering possibilities, we must not lose sight of the risks. Space mining could bring about unknown environmental consequences both on Earth and on Titan. The extraction of hydrocarbons on such a massive scale could contribute to climate change and other environmental issues. The future of space mining is a tantalizing prospect, one that could reshape our economy and our perception of wealth. But as we stand on the precipice of this new era, we must ask ourselves, are we ready for the challenges that lie ahead?